They ask you to look at those questions. They are part 1 exam. They are part 1, like exam 1. Okay, so which is the no cast part? This is the no cast part. So what we'll do, how about if you see a question, a normal distribution question on part 1 exam? Okay, you don't have calculators. How we can, if I ask you to calculate some probability, you need to think about that diagram. You assume within 1 standard deviation that's 68%, within 2 standard deviation that's 95%, and within 3 standard deviation that's 99.7, and then you will have this diagram here. So everything will be converted into Z. Okay, so any distribution needs to be converted into Z first. So we talk about on Z what we have in between 0, 1, and 2. 0, 1 to 3, -1, -2, -3. So see example 2. Example 2 says the heights of young women are normally distributed. Let's set the height of the woman be X. I just have no space to do it. You will say let X be the height of something, because you don't have random variable, you can't start from an X, like where's your X, what's your X. So X is a normal distribution with mean 160 and standard deviation 8, so it's 8 squared, so that's sigma squared. You can write 64 there, that's the same thing, but just easy to see that's standard deviation 8. Okay, so what I want to do is I want I want height, probability. What's the percentage of women whose height is in between 152 and 168? Okay, I want the probability of that. And what I will do, if requires working, if it's 1 mark question, I can directly give the answer, count how many standard deviation are there. But if it's like 2 mark question, it requires some working, I will convert that into a Z. Or a lot of part 1 exam question will give you, given that probability Z greater than 1 is what? Probability Z less than -1 is what? Or greater than 2. They give you you must relate to the Z. So if the Z -1, -2, -3, or 1 to 3 was given in the question, then what you need to do is convert into Z. So to convert that into Z is 152 minus 160 divided by 8 less than Z less than 168 minus 160 over 8. There's no space. What I'll have is probability Z in between -1 and 1. Okay, that's the probability in between 1 standard deviation is exactly 1 standard deviation. So what I will have is 0.68, or you can say 68% in between -1 and 1. You can see that 0.68. So that's why I have that diagram there. I want in between 168 and 184. So that's probability 168 to 184, and what I will have is, well, if you minus 160 divided by that, that's 1, and that's changed to Z. 164 minus 160 give you 24. 24 divided by 8 gives you 3. So it's in between 1 and 3. The Z is in between 1 and 3. If you look at that, in between 1 and 3 is 0.135 plus 0.0235. If you look at there, that's the probability. What's that? 0.1585. I think that's right. Calculator. Okay, so we look at that the normal distribution on the board, and then we just have 0.135 plus 0.0235. Okay, greater than 176. So it's the probability X is greater than 176, and that's the probability that Z is greater than minus 160. We have 16. 16 divided by 8 is 2. So it's Z greater than 2 standard deviation, greater than 2. So what I will have is 0.0235 plus 0.0015. Well, I should do it by hand. So 0.025. 0.025. 2.5%. Less than 136. That's probability that less than that minus 160. That's minus 24. Minus 24 divided by 8 is minus 3. So is 136 minus 160. 136 minus 160 and then divide by 8. So it's minus 3. So is that less than minus 3? What we have is 0.0015. Okay, so those 4 questions are exactly the same. They're very typical exam 1 questions. It just show how we convert x into z and how we use the standardized normal distribution, and within 1, 2, 3 standard deviations, what's the probability should be. Okay, so we're just using that to look at the probability. What I want for the next one is find an interval which contain approximately 95% of all the possible heights. We see 95%, we know that's within 2 standard deviation. Okay, that's within 2 standard deviation. So 160 is the mean, 168 is the 1 standard deviation, 176 is 2 standard deviation, minus 8 is 152, minus 8 is 144. Okay, so what our answer is in between 144 to 176, that cover about 95% of the height. Okay, 95% of the height. Approximately possible height. Okay. Okay, find the highest 16% of the possible height. Okay. So I have a normal distribution. I want the highest is about here. How many standard deviation away from the mean is actually here? If I want that is 16%. Look at all these values. Which one get a relationship between 16%? 0.16. The right hand side. You can keep adding from the right hand side. So if you really can't see it. So we have 0.0015. We plus what? 0.0235 plus, well, that can't be that, right? And then plus now 0.0235. 0.135. 0.16. Well, 34%. 50% minus 34% is 16%. So 16% is how many standard deviation? Mu plus what? Mu plus 1 sigma, right? Is 1 standard deviation away from the mu. So is actually above 168 centimeters. 160 is here. So 168 for the next one, because here is 0.34 and then the next section is 0.16. That's the highest 16%. Well, I can have 16% anywhere. Okay, I can find the 16% anywhere, but I want the tallest 16%. So it's from 1 standard deviation and above. Okay. All right. For example 3, find the mean. Okay, this 2 pages is all what's it called, non-cast questions, so you don't have calculators. Find the mean and standard deviation if a normal distribution has a symmetrical region. Okay, symmetrical region is very important. In between those 2 things is 95%. What you should understand is not only within 2 standard deviation give you 95%. Say I have from here to here, I got 95%, right? That's like mu minus 2 sigma and mu plus 2 sigma. That is approximate 95%. That's a symmetrical region, okay? Symmetrical region. But how about if I have a distribution, exactly same distribution? That's 5%. Well, that's not 5. Let's say that's 4%. And that side is 1% here. So in between A and B, I will still have 95%, but that's not a symmetrical region. Can you see that? So only within 2 standard deviations, I can have a symmetrical region of 95%. So if I have 1% here, and then 4% here, I still left with 95%. And that's possible. You know that's possible, and you know that's not going to be symmetrical. So therefore, when they measure symmetrical region, must be in between the mean. Okay, in between the mean. Means in the middle. So what we have, how we can calculate the middle for those two numbers? How I can calculate the middle? What's the middle number? How do you calculate middle? Yeah, it's just the average. Good. I just want to hear that. So mu is the average between that 168 divided by 2, 84. How do we calculate the standard deviation? How many standard deviation are there in between those two numbers? 2 left, 2 right. Okay, so there are 4 standard deviation in between, within 2 standard deviation, left and right. So how we can calculate the standard deviation? How we can calculate standard deviation? What's the distance in between them? What's the distance? How do you calculate that? What's the distance in between 1 and 5? How do you calculate that? You minus them. It's not fun. And how many standard deviation are there? 4. So I need to divide that by 4 to get my 1 standard deviation distance. No, it's not trick. It's an easy question. I just want to ask how to calculate. Okay, that's it. So mu is 84 and standard deviation is 16. Because you know that's in between 2 standard deviation and then mean must be in the middle. So we calculate the midpoint and then we calculate what's the distance in between the 2 values. And you know there are 4 standard deviation covered and divide by 4 you have your standard deviation. Okay, it's not a trick question. Very easy one. Just rely on your basic understanding on normal distribution. Well, next question is the same. I have mu, I have standard deviation. I want to find probability in between that. 24 minus 60 divided by 12. Set 72 minus 60 divided by 12. So what else to calculate? This is the probability. 36 divided by 12 is minus 3, and that 12 divided by 12 is 1. So it's in between minus 3 to 1. So it can be 0.5 minus 0.0015 and then plus the 0.34. On the left hand side of 0, I only missing the last bit because it starts from minus 3. So I don't have the 0.0015 part. And then until 1. So 0 to 1 is another 0.34. So I will add that part on. Well, there's multiple ways. Or you can just add them one by one. That will work as well. So 0.5 minus 0.005 plus 0.34. What I have 0.8385. Okay, so all of this is practicing how to convert the question into a Z and then use the Z like 1, 2, 3 standard deviations to work on probability. Okay, for 5, Z is in between 0 to 1. Z less than A is 0.72. Let's sketch for this. Okay, it's a standardized normal distribution. It's a standardized normal distribution. A should be a negative or positive number. A must be positive or negative. It must be positive, because if it's negative, the area less than A can't be greater than 0.5. It's on the left hand side of the whole distribution. So A must be positive. So A is approximately here. And I said 0.72. This is 0.28. On the side, like less than A is 0.72, then greater than A is 0.28. So for the first one, I have 0.28. Less than negative A. Okay, so my negative A must be here. Okay, negative A is symmetrical. So less than negative A is the same as greater than A. So it's 0.28 as well. Greater than negative A will be same as less than, greater than negative A will be same as less than A. Okay, same region. So 0.72 for that. In between negative A to 0, which is this region here, that's 0.5 minus 0.28. Well, minus the less than A part. So that equals to 0.22. 0.22. For the next one, I need to find intersection between the two sets. The first set is in between 0 to A, which is here. The next set is greater than negative A, which is that. So what I'll have, what's the intersection is 0 to A, right? 0 to A. So it's the probability that 0 to A for intersection divided by a probability Z greater than minus A. In between 0 to A is the same as negative A to 0, which is 0.22, and divide by greater than A is 0.72. Yeah, that's all the values we have worked out before, and that's 22 over 72, 11 over 36. Okay, if not asking you to put in decimals or rounding to how many decimals, you keep your answer in exact form. So fraction will be a preferred form. Okay, these are questions. Just basically look at the graph and I can find them. Not very difficult. Let's have a look at the next one. X is a normal distribution with X less than 8. Well, it's not a standardized normal distribution anymore. It's just a really normal distribution. The normal distribution just looks like this. And have mu here. Well, I don't know what's the mu, but mu somewhere. X less than A is 0.27. Is that my A should be on the left hand side of mu or right hand side of mu? Left hand side, okay, because it wants to reach the 0.27. So if it's 0.27, that's approximately here. That's A. Okay, here. So 0.27 here, less than A. Okay, and B. B must be left-hand side or right-hand side? Right-hand side, right? Less than B is 0.81, which is approximately here with 0.19 for this area. Okay, 1 minus 0.19 give you 0.81. What's this area here? Or that's one way to do it. Can't be 0.5. It can be 0.81 minus 0.27 because less than B is, okay, left hand side of B, everything is 0.81, less than A is 0.27. So subtract them is the area in between. Well, it's all correct. It's just another way to think about it. So 0.54. All right. So what we can see here is in between. Well, if you need working, just write the working down, 1 minus that or minus that, or draw the diagram or whatever I put there. Okay, A is here, B is here. I want less than A given less than B. So less than A is here, less than B is here. So what I will have is probability X less than A for the intersection divided by X less than B. Less than A gives me 0.27, less than B gives me 0.81. Okay, it's given in the question, 0.27, 0.81. Divided by 9, that's a 1/3. That's just 1/3. Okay, 0.27 times 3 gives you 81. So for this one will be X greater than B for the intersection divided by X greater than A. There. Then what we have is greater than B is 0.19, greater than A is 1 minus 0.27. That will give you the greater than A value. That's 0.19 over 0.73. That's 19 over 73. Alright, so these 2 pages are all exam 1 questions. Okay, are all exam 1 questions. No calculator, and I must use the standardized normal to work on it. And then I either see the graph or see the 1, 2, 3 standard deviations, 68, 95, and 99.7. And just wants to go a little bit after that. Okay, a really quick learning is just what you use for calculators. Okay, if it's part 2 exam and if it's not exactly 1, 2, 3 standard deviation is what we can do. Okay, quick answer is by CAS. Okay, if you have your CAS, you can, if you know what's the mu, what's the standard deviation, I can definitely use CAS to do it. So the function is menu 5, 5. Okay. The only 2 we use is 2 and 3. Okay, those 2 functions are the only functions we'll use for normal distribution. Okay, remember for binomial we have used A, B, C, D. We have used A, B, C, D. But for normal we only use 2 and 3. That's the only 2 functions we use. is not something we learn. See, like in a continuous random variable, we never use 1 point. We never talk about at x equals to 1 what value is. We always talk about in between something. So it's always CDF. Just what you need to remember. We only use CDF for normal. So what the question looks like. Okay. So in the following, Z is a normal distribution. In between 0 to mu is 0, standard deviation is 1. Give your answer correct to 3 decimal places. Okay, Z is less than my 1.25, less than 1.25. What's the lower bound in this case? What's the lowest value this function can take? Negative infinity until 1.25. So, and then mu is 0 and standard deviation is 1. So what we need to do is we click into CDF. And I know from negative infinity to 1.25, mu is 0, standard deviation is 1. Just, well, if you need to change that. If you don't need to, just press enter. Again, my questions. Menu 552, 1.25, and then enter. So we have 0.89435. So we need 3 decimal places and 894. Okay, 894. Well, you can do all the rest. Well, Z is greater than negative 0.5, negative 0.5 to infinity. In between that, lower bound, upper bound. So that's type in the calculator. The next function we have is, okay, this is give you the mu, give you the standard deviation, give you x less than something or greater something or in between something. We just want the area. Okay, there's also another way, another question we can ask is, I know Z is less than A, that area is 0.46, and I know the mu, I know the standard deviation. Okay, giving me the standard deviation, giving me the mean. What I have now is, okay, this is really important, okay, very, very important, because we use that. Okay, what all I know is it's a standardized normal distribution, and less than A, this is A, somewhere here, gives me 0.46. Okay, so which means on the left hand side of my A is 0.46. I should be able to work out what's this A, right? Negative infinity to A, 0.1 should give me the area 0.46. So what I will do in this case is menu 553, the inverse normal. So what you use is the inverse normal, menu 553. I want to work out a point, a known point. I don't know what's the point, what's the value is that point. But I know the area, okay, be aware of that. I know the area on the left hand side of that point. That's the area I use, okay? The area on the left hand side of that point. If I know the right hand side, doesn't work. Okay, must be the left hand side. This calculator only have area, there's no descriptions, but this area means left hand side area. Okay, less than A, less than that point. So the area I will have is 0.46. And mu standard deviation is given and is 0 and 1. If it's not 0 and 1, you change it to 0 and 1, and that's it. We click enter for that. You have negative 0.100. Okay, so that's your answer. Negative 0.100. 3 decimal places. Okay, let's have a look at next one. Greater than A is 0.8. Greater than A. Well, A must be this side. Well, I don't really care which side is that, but like I have A value, A is here. Okay, this area I know is 0.28, but that's not a helpful area. What's the area I need to use? 0.72 is the good area to use because it must be the left hand side of the point you want to work out. So I need one more step on the paper. You can't directly go for calculator. What's the next step you need to write? Is probability Z less than or less than equals to A is 0.72. I need to see that in order to use calculator. So the step before you have your answer must be whatever you will put into the calculator is 0.72 you put into the calculator. So I need that line. So that line is a method mark. You can say that's kind of a method mark. Okay, I need a line after that. Okay, because that's the thing I put into the calculator. 0.28 is not the thing I put into the calculator. So, well, just copy that down. 0.72. So 0.583. 0.583. Okay, the next one, Z, is in between negative A to A. It's a symmetrical area. Okay, that's what you need to realize. That's a symmetrical area because it's in between negative A to A. Okay, graph is so bad. Okay, so something like this, negative A to A. The area here is 0.74. And you want to work out A. What's the area you will use in this question? What your interest is A. What's the area here? So 0.26 is two sides, right? 0.13 is each side. So what's the area less than A? What's the probability your Z is less than A? That would be 0.13. So it's what? 0.87. Okay, it's 1 minus 0.13. Okay, just accept not the right hand side. Okay, it's 1 minus the right hand side. So you are interested in this point. You're not interested in negative A actually. You're interested in A. So on the left hand side of A, what's the area? Okay, you put that area in. So 0.87. Uh, 1.126. 1.126. Okay, 0.87. A value is 1.126. Okay, that's how to use area to work out a point. This area must be on the left hand side of the point, not the right hand side of the point. So all the area used is the point you're interested in and less than that value. Okay, less than that value. Not x, it's z. Okay, what to do next? Well, that's what you need to do now. Use your calculator next half hour. Use your calculator to work on that. But, okay, what's but? I want to ask you for one question, which is this one, B. Just look at B. What's the standard deviation for B? Root 23. Okay, so the place what you put in there is a variance. So variance is 23, then the standard deviation is a root 23. So that's what we're interested in. Also, what's 98th percentile? Can you describe what's percentile? From where to where is what, and if you have a normal distribution, okay, and I have a point A, what happens to this A? Where's 0.98? Left or right? Left. Okay, A is the 98th percentile. From negative infinity, from the lowest point until somewhere, you get 98%. Okay, you get 98%. That's the 98th percentile for A is the 98th percentile. So from negative infinity until A, you have 0.98 of the area. Okay, it's the left hand side. So remember, all the math we learn is the left hand side. Okay, important thing is always the left hand side. Okay, so just give you the hint. Be aware of all the standard deviation, all the standard deviation will be square root of those values because it's the variance place. Just be careful with that. So rest of time you just work on this page. Okay, finish example 7A like the other two, A, 2 and 3, and then finish example 8. That's all we need to do for today.